Hello everyone, this is Mr. Kozlowski. Welcome to Unit 4. In Unit 4 we'll be discussing energy, and today's learning target is simply to identify the forms of energy. Now, this should be reviewed from middle school. We're going to add a few little different tweaks. So for most of you, this will serve as a reminder of what energy is and what forms exist. So what is the learning target? Students are going to have to be able to identify forms of energy in a given story. So for learning target 1, the skill that essentially students will have to do is take a story or a given situation to you and identify all the forms of energy that exist in that story. The forms of energy are very simple. You will have to memorize them and basically identify them from a given word problem. So what is energy? Energy is the ability to cause change. This is going to be our working definition of energy. And this definition is not only going to be used in physical science, but it's also going to be used in biology. It's also going to be used in chemistry, as well as physics, if you chose to take those courses. So what forms exist? You probably have heard of some of these forms already. But you will have to memorize these 4 main forms of energy. Number 1, kinetic energy, which we call EK, or we abbreviate EK. Gravitational potential energy, which is EG. Elastic potential energy, which is EL. Chemical potential energy, which is ECH. And then thermal energy, which is ETH. So what are those forms of energy, and what do they look like, and what do they involve? Well, the first one I want to talk about is kinetic energy. You've probably heard of kinetic energy before. Kinetic energy is referring to the energy that exists in the form of a motion. So, for example, here we have a picture of Usain Bolt. He is sprinting. A person sprinting, he's in motion. He has kinetic energy. A spinning bicycle wheel would be an example of kinetic energy. So, not only do living things have energy, also inanimate objects can have kinetic energy. So anything that is moving is kinetic energy. There are some rules of thumb when we discuss kinetic energy. Basically, if you have more mass, you're going to have kinetic energy. The other thing is, if you have more speed, you're also going to have kinetic energy. Now, these 2 variables are going to be involved in the equation for calculating kinetic energy. We are going to do these calculations later on within the unit. The next type of energy is called gravitational potential energy, or EG. This is the energy of position. So here in this picture we have an example of a person holding a ball. Let's just say it's a tennis ball in the air. Since they are at a given height, the gravitational potential energy is much higher than a person holding the ball down at this plane right here in the picture. So again, energy of position is gravitational potential energy. Some rules of thumb for this type of energy. The higher the position equals more gravitational potential energy, and then also the more mass equals more gravitational potential energy. You may remember the bowling ball example, the bowling ball in the feather video that we watched in class. Well, that would be an example of more massive object. They are dropped from the same height, and we discussed this, that yes, in a true vacuum, they will accelerate at the same rate and hit the ground at the same time. However, which one has more energy? Well, the one with more mass is going to have more gravitational potential energy because just simply because it has more mass. We talked about that. Which would you rather be hit in the head with, a bowling ball or the feathers? It would be the feathers because they have less mass, less gravitational potential energy in this case. Elastic potential energy. Elastic potential energy is energy that is stored by squeezing or stretching. So examples would be a spring, a rubber band similar to your Newton Car Lab, or a slingshot like you see in this picture here. Anything that stretches is going to have elastic potential energy. rule of thumb for elastic potential energy, the more stretch or compression, the more elastic potential energy it has. So, something like a tennis ball bouncing, if it stretches or compresses more, it's going to have more potential, elastic potential energy in that case. The next type of energy is called chemical potential energy, or ECH. This is energy that is stored in chemical bonds. So if you think about this type of energy, generally my rule of thumb is to tell students, is it a food or a fuel? If it is, it has chemical potential energy. So for example, foods that you eat, like shown here, contain chemical bonds between the atoms that are in that matter. Those chemical bonds, if you break them, they release energy, so that they have potential energy locked in between those bonds. Examples of this, like I said, food, a sandwich would be an example. Also natural gas. If you think about ways that we heat our homes, you have a furnace that burns natural gas. That's going to give off heat and energy that's going to help you heat your home. You think about gas that goes into your car. That would be an example of chemical potential energy because the engine burns it and transfers that energy into something else. So that would be chemical potential energy. The last one I'd like to talk about is thermal energy, and this is energy that comes from heat. So basically, a rule of thumb for this is if there's increased temperature, there's going to be more thermal energy. For example, the sun heating the earth. Obviously, you know that Earth is on an axis tilt here, and the rays in the sun hit parts of the Earth differently at different times of the season. So, for example, in wintertime in Wisconsin, we are not getting a lot of thermal energy due to the angle of the sun. We're not getting a lot of direct sunlight. However, due to the rotation in Earth's axis, in the summertime, we get much more direct sunlight. Therefore, we have an increased temperature and more thermal energy present in the state of Wisconsin during those months. So that's thermal energy. So now that we discussed the 5 types of energy that you have to know, I'm just going to kind of go through this. Which type of energy is this? This is gas in a car tank, and gas in a car tank would be an example of chemical potential energy. Which type of energy is a book on a table? Well, that book on a table is at a raised height or a different position. That would have gravitational potential energy. In this picture, which book has the most gravitational potential energy? A, B, or C? In this case, it would be B for 2 reasons. Number 1, it is at the highest position, so it has a different height, meaning higher height, more gravitational potential energy. And also, you can assume in this picture, since it's a larger book, it probably has a more mass than the other books. Therefore, it's going to have a greater gravitational potential energy as well. Fireplace. In this one, there's actually 2. Obviously, there's thermal energy because you get heated from the fire itself. And as well, you're going to have chemical potential energy because the flames break down the bonds, the material in the wood to allow it to keep burning. So understand that in some cases, you're going to have many examples of different types of energy in the situations that I give to you. The wind, the moving air, you could have all different types of energy in this one. You could have obviously kinetic energy because the air is moving. Also, there may be potential energy because the winds might blow at different heights. Some kids have reasoned with me on that one. I guess I kind of agree with that. But understand another situation where you could have more than one type of energy in this case. Coal. coal would be chemical potential energy because of the chemical bonds stored within coal. If you were burning coal, it would obviously, you'd create thermal energy there as well. Compressed spring, obviously compression, that would be elastic potential energy. Type of bike, at rest at the top of the hill. If the bike is at rest, you would have basically gravitational potential energy at the hill. If it was moving, you would obviously have kinetic energy in there as well. The moving ball here in this picture, obviously you're going to have kinetic potential energy. And then also some would argue that since it's a ball, that lacrosse ball, which could stretch and compress, some people would say, well, it's elastic potential energy, which is true. It does contain that. Which one has more kinetic energy, a fast or slow ball? It is obviously the faster moving ball, the one on the left. Dog running. Would be obviously kinetic energy, and some would argue, well, the dog needs food, fuel to run, needs energy to run, so that would be chemical potential as well. Which has more kinetic energy in this case, a big or a small dog? It would be probably the big dog, just due to its overall mass, assuming that they're going the same speed. Finally, which type of energy is water being heated up? In this case, boiling water. That would be thermal energy. And then also the water molecules moving, that would be kinetic energy as well. And which would have more thermal energy? It would be the boiling water, because more heat equals more energy. So that's about it. If you have any questions on energy, please let me know. You'll get a lot of practice at this. And let me know what you think. Don't forget to do the quiz, and I'll see you guys in class. Thanks.